This video will show you how to build a simple robot Arduino car. There'll be other videos where I show how to add like robot arms and other cool stuff to this robot. This is just a base, so there's lots of fun things you can do.
No. Can't do it. I'm going to make this cheap Wally robot. I want it to look a little bit like Wally, so there's going to be a storage compartment where I can put things in with a door, and here there'll be all the electronics, the Arduino and everything. So I'm just using these like $1 US gear motors and these cheap tires, and I'm just going to take this one, which is like a 3-wheel drive robot that had a wheel in the front with this Lego wheel, and I'm going to put 4 wheels so that it can go over the bumps I have in my doorways in my house, because I wanted to program it to drive all around the house. I'm going to use the same, just 2 Mosfets, and I'm going to have each Mosfet powered 2 wheels, and it's just going to be able to turn by powering one side or the other. And I'm going to have the same eyes here, which is ultrasonic distance sensor. And I just mapped this out, so I have 1 square equals 1 centimeter, and then I kind of just drew everything out where everything's going to be. So I'm going to start with just the bottom platform, and I'm going to glue the electronics and motors and everything on there and drive it around, make sure it can go over bumps, maybe add some weight higher up to see if it's going to fall over, and then I'm going to make this frame that kind of bolts on top. So there's just screws through the bottom that hold the whole top box on, and all the electronics is then on that bottom plate. So yeah, the total cost of this robot with these motors is about $4 in motors. The MOSFETs, the Arduino's a few dollars. So I think it's about $10, and it's a robot that you can add a lot of functionality and change. So I'm going to have servos running arms, servos running this door, you can have the head move, you can do a lot of things, add some sounds and that kind of stuff. And it'd be really fun just to program it to go around the house or to get stuff and see how far I can take this. And then I want to build a bigger one for outside that has gear motors, like a electric drill motors here. Make it more powerful so it can drive like through the woods. This first robot was using cardboard and some popsicle sticks for reinforcement, but it's not very strong. So the next robot I want to be a lot more robust. So I'm going to use this MDF board. It's 5 millimeters thick. It's very strong. So I'm going to cut that out now. Basically just have to take the measurements here from this bottom plate and cut that out, and then I can glue and mount everything to the bottom plate and test that.
So I marked off the bottom plate on this piece of wood, and I'm just putting the motors there to make sure that I have enough space. It's time to take apart the old robot and build a new one. Before assembly, I solder wires to the motors. Quick test with a AA battery to make sure the motor spins. So I just use hot glue to glue this power bank and the 4 gear motors directly to the wood piece. Apply some glue on the bottom and then press it into place. I need to upload the program to this robot, so I'm starting up my Raspberry Pi computer. I do all my Arduino programming with my Raspberry Pi. It's just really easy. And then I have to unplug. This is where it gets power, but it's also how we download a new program. So I have to unplug that micro USB, and I open up the program here. This is a program I wrote previously, so it takes ultrasonic sensor distance, and when it gets too close to a wall, then it turns around. Shows how far away from the wall it is and how long it runs the motors to turn. So I take this plug, which is connected to the Raspberry Pi, and I'll plug it into the robot. And then I can upload this program onto the robot. It's just very easy to make changes here and upload it from the Raspberry Pi onto the Arduino that's part of the robot. And now it's running.
Perfect.
So this is a great thing. It's rechargeable. So when the battery's running low, I unplug this power USB, and then I plug in the micro USB, which is connected to a wall power charger, just like your phone. And then this power bank is blinking, so I'm charging the robot. And now I waited a while, and now it's fully charged. I can unplug it, and then I can drive it again. So it climbs quite well, but here there's a little bit of a problem. Flips over. And then it's kind of like a dog if you hold it above water. It's trying to run still. It sees the ground. It wants to go in a circle. This robot only has 1 MOSFET per motor, so it can only go forwards or off. I'm going to add an H-bridge later so it can actually go reverse too, and it can spin on the spot.
So I wanted to explain how this little car works. So there's this power bank that you use to like charge a mobile phone, right? So you can take power off it with this USB plug, and then you can charge it with this micro USB. So that makes it a rechargeable car. This is like a lithium ion battery that's in there. Then we have these two 5-volt leads that come out. The red is positive, and then the blue is negative. So you can see that it goes to the main negative bar and positive bar of this breadboard. And the stuff that uses the negative is the Arduino's hooked up to the ground on negative. And also the Arduino is powered here by the ground and the positive. So that's the power for the Arduino. And then also both of these Mosfets are connected on the pin here all the way on the right side. For both of them are connected to ground. So this creates a circuit from the negative side here. It breaks it open with this MOSFET. So when these MOSFET get signals from these two pins on the Arduino, there's two pins here from the Arduino, and each one then activates one of these MOSFETs. And these two MOSFETs then are connected to both motors. So the one on the left here is connected to both motors on the left. So that's how you turn on the left motors. And then here, if you activate this, it turns on the right motors. If you activate both, it goes straight. One of the other ways it turns. Yeah, and then these are activated, and that closes that circuit. So the batteries then are the motors are directly connected to the positive here, and then the motor negative goes through the MOSFET. So when you power the MOSFET, it completes a circuit that you can get electricity from the positive through the motor and then through to the ground. When you're not activating the MOSFET, when you don't have power here, then the MOSFET is basically open, so you don't complete the circuit. And that's how you turn on and off the motors. That's it. And then there's some wires as well connected to the ultrasonic sensor in the front. But then you can add so many extra sensors. There's so many pins here that are open on the Arduino. So the idea is that this is a very simple car that you can use. The way it is right now, I could program in the Arduino to turn and go straight so I can drive around my house and I can try and do different paths. So that's a great way actually to learn programming. But then I can add whatever sensors I want to make this really functional. So the reason we need these MOSFETs is that the power that comes out of these pins is very low. So you can have something like 5 volts and 40 milliamps. It's very, very low. It's not enough to power any of these larger motors. So what we do is we send this power through a resistor. This is something like a 200 ohm resistor to make sure at 5 volts we have below 40 milliamps of power. And we send that power to this MOSFET.
So I attached this charge doctor to see how many amps it's pulling. And you can see here it's pulling something like 0.4 amps. I'll show it again in slow motion so you can see a little bit better. There's some peaks around 0.7, but this just shows from this power bank, this car should be able to run for something like 8 to 10 hours. So you could just put it in your living room and have it drive around and detect walls, and you wouldn't have to charge it for about 10 hours, which I think is just great.